Hey, welcome to group number 3. We're doing lesson number 8 of the problems. We're going to start off with Sky with number 1, and we'll get that going. Sky?
All right. So number 1 says, suppose that an individual is heterozygous for the following inversion. And it gives you the normal inversion chromosome. And it says, suppose that these 2 chromosomes replicate prior to meiosis, producing 4 total sister chromatids. The 2 replicated chromosomes then attempt to synapse during prophase 1. What is the allele and centromere composition of the 4 products of meiosis if there is a crossover between S and T? So what you end up with is LMN, then you have a centromere, OPQRS, and then you'll have the little t, UVQPO, and ML. And then you'll end up with one that's the XWRS, then the big T, big UVWX, and that one doesn't have any centromeres in it. And that one, and both those top two are missing alleles. And then you end up with the 2 that you started with, the inversion chromosome, which is LMN, then centromere OPQVUS or VUTSRWX, then LMN centromere OPQRSTUVWX.
Yep. Okay. Then Sophie got number 2, right?
I have number 2. So fill in the blanks. Non-disjunction in meiosis 2 produces 50% aneuploid gametes, whereas non-disjunction in mitotic and mitosis can produce a mosaic phenotype. And meiosis in an individual who has suffered a paracentric inversion produces a dicentric chromosome and an acentric chromosome. And Turner syndrome is an example of a human disease caused by monosomy, while familial Down syndrome is an example of a disease caused by Robertsonian translocation. And the human liver cells can be 4N, 8N, or 16N. Then E, a terminal deletion in chromosome 5 causes Cri-du-Chat syndrome, while an inversion on the X chromosome causes type A hemophilia. And a duplication is a change in chromosome structure that can be potentially beneficial to an organism or an entire species. And then G, when a translocation cross is formed, the alternate segregation pattern can produce viable gametes and offspring. And that's it.
Awesome. Okay, so I have number 3. And for number 3, so the total number of chromosomes that would be found in humans that have the following conditions. So for Turner syndrome, due to the lack of an extra X chromosome, it is only 45. Jacobs, we have an extra Y chromosome, and so we have 47. For Cri-du-Chat syndrome, after the partial deletion, there's still 46, but 1 chromosome is missing, the P arm, 5th chromosome. Familial Down syndrome is also 46, including the Robertsonian translocation chromosome. Then type A hemophilia is a result of an inversion, so there's no deletion of a chromosome, so still at 46. For B, which of the following is not associated with Charcot-Marie tooth disease? The ones that are not part of it is the triploid, aneuploid, reciprocal translocation, trisomy, and non-disjunction are all not part of the Charcot-Marie tooth disease. And then for C, associated with which of the following are associated with Klinefelter is aneuploid, trisomy, and non-disjunction. And which of the following are associated with type A hemophilia? None of them are associated with type A hemophilia.
Yeah, which leads on to number 4, which is me. So number 4 is kind of interesting. I got lazy, and so I just posted the diagram that's in the slides. I'll show you it now. So it's really simple, actually. So it's asking pretty much 1 pair of homologous chromosomes in a mouse that has alleles, blah, blah, blah. Another pair of homologous chromosomes that has following sequence of alleles, blah, blah. So you have 2 sets of sequence of alleles, supposed to reciprocal translocation occurs. Between 1 chromosome in each pair, following arrangement of 2 of the 4 chromosomes is this, and then this. On the other, note there's still 1 chromosome with the original parent and another one with the original parent arrangement. The star indicates location of the centromere. And so the first thing it asks you to do is diagram the synapse of the these chromosomes. So the diagram they're looking for, if I can zoom in enough for you, is this guy right here. This is the diagram they're looking for. And so what you're going to do is you're going to take the original parent type, and it's going to sit here and here and here and here. So you're going to end up with 2 of each of these parent types right here in the original segregation, which is, and then it asks for the other location cross, which are going to be here and here, and that's going to be your split cross chromosomes, as stated. Or it's going to be these guys up here, this guy and this guy. Those are going to be your crosses. And so that's the diagram they're asking for. Then it says to identify the allele composition of gametes produced by the alternate segregation. Again, it's in the diagram, and it's posted right here. So this is what you're given for the alternate segregation. You're going to end up with 2 of each cell of these, and then it's identified the alleles in the adjacent 1 segregation. So you're going to have with both of those. Again, 2 alleles of each set of these chromosomes here, and then the final one, adjacent 2 segregation. Very rare because it's like super overlapping these chromosomes here. So notice that you have the original parent one, and then you have the slight change, the 3 change on those 2. The original parent, I listed those there, and then this is the most, or the least change, there. So that's kind of how that works for number 4. And again, if you're watching this video, you definitely need to write those out. And when I turn this in, I will definitely be writing out the diagram. That's part of the problem. So we're going to go on to number 5, which is Eliza.
Okay. Cats have 38 total chromosomes. How many total chromosomes we found in the following types of cat? So for a triploid cat, you'd have 57. A cat's monosomic chromosome 12 would be 37. A cat who has suffered terminal deletion in chromosome 7 has 38. And a cat that has suffered a Robertsonian translocation between chromosome 17 and 18 has 37. A cat that has suffered a reciprocal translocation between chromosome 6 and 9 has 38.
Yep. And that is group 8 here, or group 3. Thanks so much for joining us, and see you next week.